for coming today. I think we have something interesting and different for you today. Anybody who gets up and programs live while we watch, I think we have to give extra credit to. So I was at Macworld about 2.5, 3 weeks ago in San Francisco, and I'm walking around and there are all these apps for the iPhone and all these cases for iPads and all these obscure things. And suddenly over here in the corner, there's this little company called MLstate, which is showing a programming tool. And so I met Henri and a couple of his colleagues and and we got to talking. And I said, well, you should come and give a talk. So here we are. So Henri Binsztok is a PhD in machine learning, actually, from the University of Paris 6, and studied physics. And so now, like many people here in Silicon Valley, he's on the way to being an entrepreneur. On the one hand, having this language, and on the other hand, trying to figure out how to make a business out of it. So what Henri is going to do for us today is tell us a little bit about OPA and some of the design philosophy behind it. And then it's kind of learning by doing, which is what we do here. So we're going to learn about the language while he writes code in it. So without further ado, here's Henri.
Thanks, Tony. So yeah, hi everybody, nice to meet you. So I'm going to present you how we develop web applications with the OPA language. So if you want to reach me, my email is hb@mlstate.com, and I'm tweet under Henri_OPA. So we all know what web applications are. They are the future of software. It's software that run in one of those 5 browsers, generally. And if we say it's the future of software, it's because of a recent evolution of the web, which is HTML5 in particular, and which brings many of the features that were lacking in the web platform. Audio, video, 2D, 3D, access to devices, everything that was lacking in the browser is, or almost, is now possible thanks to HTML5. So we can write almost any app as a web application. But we face 2 problems in doing this. So the first problem that we could tell is the brick wall problem. And let's go back a bit to the history of the web to explain how we get there. It started out pretty simple. The web, you have a web browser who sends HTTP requests to a web server who basically serves you static content, part of it being in HTML. And that's a way to serve hypertext between a client and a server. Pretty easy. But soon, many people added, and they were right, languages, so that we could add computations on those servers. And as well, databases to store data permanently on the servers. And at some point, we also added CSS, a way to make nicer web pages. And almost at the same time, some people at a company then named Netscape added a language in the browser as well, a different one. What a good idea. Basically, and therefore to exchange data between the client and the server, it was better now to add some more formats like XML data and JSON, which is a common way to be more efficient than XML to exchange data. Okay, let's not stop here. So once the application gets more and more complex, of course, you need some framework to get things done a bit quicker. And then also some object relational mapping, because at the time, most of the database you would use were relational. And basically, it helps having a system which does the interface between the database and the language. All this can sometimes become pretty slow. So to accelerate it a bit, you can use memcache or some cache that you will put in front of it, so that everything is done a bit faster. Okay, so now we have one client and one simple server, but the real picture is you have many clients. That's the web. You want to build a startup. You want it to be successful. You want many users. So you distribute the servers, the language, the database, of course. So you do things. And all this is basically the infrastructure you get. Because here, indeed, you have still to code your application on top of it. So, okay, let's go to problem 2. So this is the other problem, and then we'll see how we solve it. Here in Silicon Valley, there are many bright developers, very talented developers, and I guess you are among them. So you can build great things, very nice things like this. But indeed, it can sometimes be a bit fragile. So all of you, I guess, are familiar a bit with JavaScript. So one of the problems of JavaScript is that we're lacking real types. And as you say in English, comparing apple to oranges. And in French, it's with vegetables. We say comparer des choux et des carottes. So let's go to JavaScript. So we have two types involved here, integers and strings. Let's say that you have a business model, two kind of customers, direct and indirect customers. Let's say you have one direct customers, two indirect customers. So the first expression in JavaScript, pardon the codes, they are typed on Keynote. Direct plus indirect, 1 plus 2 equals 3, so that 3 customers as a string. The second line, if you write customers first, plus direct plus indirect, of course, as you may guess, you all know the answer of it. Customers plus direct becomes customer 1 as a string, plus indirect 2 becomes customer 12 as a string. So that's very cool. We got 4 times more customer. Your boss must be very happy about the code you're writing. But yeah, that's only a slight difference in the code. So let's switch at another piece of well-written JavaScript code. Something very clean, as we have here. So function foo, 3 arguments, a first n. So we're just counting, a is an array, we're just counting the sum of some elements in that array. So between first and n. Nothing very special here. So if we count foo a1, 2, basically we are computing a of 1 plus a of 2, and this is working well. Except that, of course, except this here, when you compute first plus n, because if n here is a string, and that's very easy to have a string in JavaScript, everything is untyped. You just take the data from an input, it's a string. So first plus n as a string, okay, so that's 12 again. Oh, too bad. And you have to deal with it. So what you do if you're a good developer, and if you want to be highly paid, of course, you have to be a good developer. You add something like this, n int, or even n, because that's even better if you keep the same names, is n minus 0. So now you're happy, it's an integer, and then, of course, the code will work as you entered it. It means the semantics of it is the one you had in mind. Another example. If you write if x equals 0, then we retry, x minus succeed, else we say an error, and we can write it as well as a switch in JavaScript. You know that's pretty well. Could you tell me what's the output of both if x is 0 but as a string, as always? Do you know the answer?
It's going to be an error. I mean, if x is just a pointer to a string, it's going to be an
Indeed, if you do this in JavaScript, x equals 0 as a string, pardon again the codes, they were just typed pretty quickly on Keynote. Here you get retried, because 0 as a string equals 0 as an integer for JavaScript, of course. But not so with switch. Ah, why that? Because switch does physical equality, so here it's not equal. So that's an error. But if you are talented JavaScript developers, you've got to know this. So we're like in the Middle Age, you know, with Alchemy. Alchemy, the goal was to transform a metal into another, which in that case is gold. And with JavaScript, what you do is you cast values, and you try to cast value as much as possible until you have your gold value, the gold value being the one you want. And sometimes, how do you make sure it's really the one you want? So just some cases which are taken from a guy named Gary. Do you know the output of these wonderful constructions in JavaScript? Array plus array, array plus object, object plus array, object plus object. So JavaScript is typical of a dynamic programming language in which everything succeeds. So here, do you know the answers? Yeah, if you have seen, this is taken from a video named What? Without further ado, array plus array is an empty string. That's usual. And here, an empty object. But if you switch the order of arguments, it becomes 0. Why that? And of course, object plus object is a number, which is a float, but not a number. That's super. So if you're coding in JavaScript, and of course, JavaScript should be involved many times, you're dealing with it. No semantics, or it's even better, it has a semantics. Because, and there are even guys, there's one guy at Stanford who's working and now doing his PhD, trying to figure out a formal semantics for JavaScript. And you can look at what he has. It's growing bigger and bigger and bigger. He's a PhD student of John Mitchell. It's bigger and bigger and bigger and bigger. And as a developer, if you don't want to write bugs, you've got to have all these semantics in mind. And I can warn you, it's a crazy one. Because all this was not made on purpose, basically. There's no single guy who thought that this would be the semantics of its language. It just happened to be this because it's implemented this way. So, okay. Semantics by implementation. And usually this leads to, you know, when you manipulate strings in a web application and you don't do it very well, often then you get programming errors, which turn out to be vulnerabilities like cross-site scripting attacks, SQL injections. All this come because you handle strings and you do some mistakes at one point with them. And with untyped languages, that's too easy to make. So that's why, to solve these two problems, we worked on the OPA language. So what's OPA? Just one slide of history. So it was a pet project almost 10 years ago. I was really mad at writing PHP code at the time. So I tried toying about and thinking about what we could do to make it better. But it really started in 2007. So we have worked a lot. There has been a total of 100 man-years of work in OPA as an open source product like it is today. And we released it in June last year. So it's a single language to write web apps. And it's a safe language to write web apps. So I will go into both. So first, a single language. With OPA, you can write the client code, the server code, the database code, the distribution directives. Everything is written in OPA in the same language. So the client code you write in OPA, it's translated to JavaScript. The server code you write is translated into native code. And the database can be translated in database queries for external databases, or we have also an internal database, so we generate directly database queries. And all the configuration part, which here is under the distribution, is also handled by the language. Because if you want to have a semantics of an app, and you put many things in your code, but you still have bits of it in the configuration, maybe the mistake will be in the configuration, even if your program seems to be perfectly correct. And we also, in doing OPA, rewrote most of the runtime of the apps, which means that we have OPA binary servers, which run natively on operating systems, so Linux, BSD, macOS. And optionally, you can have an external database because honestly, the internal database of OPA is not meant for big data, so it does not scale out very well. So if you want to scale out and big data, you need another database like MongoDB, for instance, which we support. But you can use the internal data for small data and, for instance, sensitive data. So, okay, enough talked. Now we could. Hello world. So let's go here. So this will remove this.
Do you provide debugging directly in OPA, or do you have to debug in the translated language?
In fact, the best way, we can talk about debugging maybe later if you want to. Okay. So here I just write a single language. I just compile. So my program is basically 4 lines. Here I start a server. It's an HTTP server. It runs a page, a single page, which is a function. The function returns always hello world, which is a bit of HTML. We'll see later. And it has this title. So I compile it. I run the server. Okay, so I open the URL, and that's hello world. Perfect. So I have written a very, very tiny web app. Just says hello world, compile, generates the binary, and runs it. So that's it. Yeah, better if we go here. Okay, so that's what we've seen. Write, compile, open, and that's it. So regarding the syntax of OPA, we chose a syntax which is close to JavaScript, so that if this is some actual OPA code taken from a real project which has been done in OPA by one guy in Chicago. So this is code that you can read if you are used to existing web languages. But it has some extra powers. One of the features is having HTML and CSS as first-class values. And this is without codes. So from the parser to the typer to the whole OPA stack understands that this is HTML fragment. So here, for instance, we say line equals an HTML fragment. And as well, we can say that we can have selector, which is here a value, equals pound foo, and foo being the selector of an ID in the user interface. And as a joke an echo to C, we used a star pointer-like syntax to say, okay, we can put the content of line into the selector, which is pointed by the selector. So this is what you can do. Is really meant for the web, so you can manipulate web. We favor reactive programming. So basically, you can write a function, which is an action, and this function puts this HTML element into pound foo. And later, you can say in your code that you have a div, an element, where if you click on it, then you call the action function being here. And this is, we'll try it. This is pretty convenient. So, okay, let's try it. So, here, it's a bit different, but it's almost the same. So I have my function test. I have my line. I put my selector. My selector is point ID, and then I put the line into the selector. So I just go here. I start my server. I compile my program. And I just run it, and I open it. So now it's like the previous one. It's like Hello World, but if I click on it, it says clicked. So that's typically the reactive programming. Okay, let's continue with some more features. So this is basically the program we have now. So just something simple. Client and server. Okay, so if you write code, you can write the whole code without telling what runs on the client, what runs on the server. If you have the previous example, turns out that the function which sends the original Hello World content comes from the server. And the local click event reaction, this runs on the client. It has been translated to JavaScript. But this is done automatically. So in fact, you could write a whole code without telling which parts are server or client, or you can add some hints. So for instance, this is also taken from a real OPA program. Here you could add server or client or just nothing before to tell whether it's running on the client or on the server. And we feature a transparent distribution between client and server, which means that you don't have to think about synchronizing the context or sending values from the client to the server. We take care of that. So we analyze what are the values needed by both sides to make the communication happen. Turns out that it can be pretty dangerous. So we have several keywords to have a precise control over it, and we favor the non-dangerous approach. So we've seen client versus server. Very easy. Run on the client, run on the server. Next annotation, or next effect, exposed versus protected. Suppose we are writing an application, and let's say that we have here some data, and let's say that we call it. So I go into some more advanced feature. Let's say that a user is a name and a password. And somehow you are having, let's say, I won't put it in database yet. Let's say you have a value, which are users, which is a map. Okay, to start with, it will be an empty map. But let's say that this is to be the map of users. So you are creating a lot of users with a name and password. Typically, this kind of stuff, you don't want to send it to every client that connects. Even if your password is a hash, which you should, even though you don't want to send your whole table to any client. So that's why you could tell, for instance, that this is protected. And if you protect the value, it means that this value won't be sent to the clients. But it is the default, indeed. So you rarely, if you write it, it is really to enforce it and to really make sure that that it's the case in some complex situations. But the contrary is exposed, where you can tell, and this is definitely not the default, you can tell, and we will see it in an example later, you can tell that this value can be seen by any client that connects. And so this is the exposed. You can have also synchronous or asynchronous calls between the client and the server. So of course we favor asynchronous, but you can force synchronous calls with sync and async. And just because it was asked several times when I told this, It has nothing to do with public versus private, which is linked to the package system, and see whether a given function is public or private, as in any other programming language. So let's go to another feature, which is the data access. So you could write database read-only queries very easily in OPA, and you can also update database. So for instance, you can put the user value into the database. Here, the database, we are using the user's path, and with a key which is username being a parameter of the function here. But it's just an example to show, and we'll do a real program now, that you can have queries and you can have updates as well, everything in the language. So just to give you an idea, we have a very complete binding of MongoDB, and almost all the MongoDB features are bound into OPA. So you could do almost every query you might think of using the query syntax of OPA. So, and we feature transparent mapping between database code and value. So for instance, if you get, you can store an OPA value, it's persistency basically, so you can store an OPA value in a database and can get it back without having to do the conversion yourself. Even for MongoDB, I guess it's probably a unique feature. I'm not aware of any other system to map complex data structures into MongoDB, determine whether they are updated or not, and try to do some maximal sharing when storing them. So this is one of the features. Here, okay, let's do this program. So here, so I'll try maybe to. So yeah, just save time typing. So here we do a database. We declare that we would have a counter which starts at 0, and then we have the action function, which is like the previously changes the text in the interface, but also at the same time updates a counter in the database. And the function page is about the same as previously, and starting the server is the same as well. So here I start my server, I compile my new application, and I run it. Okay, it told me that, and it's true that the structure of the database has changed because I've played several times with the same hello program, and there is already a database associated to it. So basically, it tells me that the node at /users was removed. It's true. I compiled a /user just previously, and I removed it in this program. And it tells me also that a new node was added at /counter. So you see, it's a proof that what's happening behind is really we analyze the data model. So we are really, for instance, building the data structure which is behind it. And here it says that, okay, those changes, I know how to handle them automatically. So I can force a data upgrade, which I'm doing now, and say, okay, he's removing my users and adding my counter, and I've got my new program. So I can open this program, like this. Okay, it's hello world again, but now if I click the header, it says, hello, user number 1. So if I refresh the page, or you can connect too. You can connect, you have the URL, I guess you can connect. But otherwise I refresh the page, and then I click the header. Okay, I'm user number 2. So you did not connect. Basically, this is persistent, of course. So if I start my server and if I restart it without the DB upgrade this time, and I refresh it and I click it, okay, now I'm user number 3, of course. So this is persistent, and all this you have written it using that much code, nothing else. It compiles into a single binary which runs on a naked Linux system, for instance. No dependency required at all. Okay, let's go into some more things. Part 2, OPA as a safe language. So, behind type safety and strong static typing is the idea that you compile your code, and if there are type errors, you detect them at compile time, you display an error, and you don't get your app. As opposed to dynamic programming, where you code something and you run it, even if it's really buggy, you can run it. Here you can't. Type checking. Okay, foo equals 1 plus bar will tell you that types int string are not compatible. Sorry. In JavaScript, it would be 1 bar, but it's not always the case. It's not always doing what you want, as we saw previously. But we feature type inference. And this is one of the goals, and the design goal behind OPA was making strong static typing available for many developers. And we don't want to annoy developers, hence the type inference. You write this, function foo s, string length s, and function bar xy, footer x plus y. But during compilation, what really happens is that the typing system and the typing algorithm of OPA infers that this function foo returns an integer, takes a string as argument, and function bar returns an integer and takes 2 arguments, the first one a string and y being an integer. So you don't have to write those types yourself, and you just get them. This is a quick map of some of the types which are handled by OPA. So at top left, we have the basic types: integer, string, and float. One of the most used type structure in OPA are records. And the records happen to be polymorphic records and extensible records. So it means that you can add fields while during the execution of the program. But this is planned in advance. So in fact, the typing system knows which fields will be added during runtime. So it's level, type, etc., etc., etc. And a very powerful feature are variants. So variants is when you have a value which is one type or another type. And the combination of this, for instance, with labels, with records and variants, you can define the Boolean, for instance. Boolean, it's a variant. Either it's the record with the field true, either it's the record with the field false. And this is how you define bool. You define option, which is also very useful, and which is the way to have none or some value. And with this, you can also define more and more complex data structure like lists, sets, maps. These are very easy to use every day. OPA is functional, so you can have function as first-class values. Function, the type of it is type a row type. So basically, you get a type as input, and you get another type as an output. So it's typical of ML, core programming language. And in OPA, you can also have modules as first-class values, meaning that you can have a function which takes a module as an argument or returns a module as an output, which is very convenient for code modularity. So you can have functors just by using these models. And one very important feature, if you write big projects, are the support for abstract data types. So basically, abstract data types are a way, when you modularize your code, to tell that outside a given scope, which usually happens to be your current module, all the other modules will be able to pass through values, but never work on them, never modify them. And this is a very, very important static guarantee that you can have, that you're not breaking your code apart when writing a big application. Just making sure that a tiny portion of your code will be able to modify it. And that's very important to enforce some properties and to guarantee some, to prove indeed that if you want to do them on paper, to prove that some properties are respected over your code. So one way to use the types are also type annotation. So you can define a type, for instance, type, and give it the name you want, for instance, user.t. And here we have a record with 3 fields. And basically, you can tell later in your code that this user value here is of type user.t. So if you did not say it, the compiler would have inferred that this is a record which uses 3 fields, username, full name, password, and would have also inferred that those fields are strings. But here we add a name to it, which is a very convenient way to manipulate your types. Okay, what are the benefits of it? So let's start with this project here, the last one, and say that, okay, I'm dreaming while I'm coding. I close a div, I open a div, I close a span in my code. So I just do a quit and don't run, I compile. And immediately you get that, no problem, that's something wrong. Here I'm closing a span and I'm opening a div, so basically I have a open and close tag mismatch, div versus span. This is your wingman when you're coding applications. This is really helpful. Some more errors which are taken from real projects. This one is pretty interesting. In this case, this is an example from a real program. This one is named web shell, and this is like a shell for web for the web. Here we do a typo. We have a small typo. We say we move left, so we forgot the T. Fat fingers. And what the compiler tells basically is that you have a type mismatch. The first time is left, and by itself because you're just founding this here. And the second type is left or rightmost or up or down. So if you look at the real web shell code, you'll understand why. I'm gonna show it to you. Where is it? It's open maybe. Okay, so this is the real code that we have here. So it's just a way to capture things, and we see, for instance, that here we define some move, and the type is never defined in the code. But for instance, we have this function here, which is later in the code. So in this function later in the code, we have case left, case right, case rightmost, case up, case down. The type is never defined. Never we write that there is a type. And in another function, which is the eval key down, so this is the function which is called when we eval, here we've got the call. So here we call move left, move up, move right, move down. And the compiler automatically detects, there are no other use of it elsewhere in the program, just those two. One function who calls them, and one function who uses them. And basically, this here is the extract with the mistake. Basically, it says, okay, the compiler detects that in another part of the code, you're using those cases, and here you have this one doesn't match. So it's up to you to figure out that you have a typo. In JavaScript or in Ruby or whatever, if it's tricky, if it's hidden somewhere in your code, it will take you a long time to figure out that you have a typo. You have to debug it and see that something you click and never works, and you figure out in the end that, okay, it never works because you have a typo, because the variable is, because here it's in JavaScript or whatever, it's 0 or empty record or empty object, it's something. It's never nothing. Another thing that is detected the same way is that if you have also typos, for instance, in function names, it will tell you, okay, this field does not exist, and using string edit distance, the compiler tells you that maybe this one is quite close. Or you can have also detection of wrong number of arguments. And again, in most dynamic programming languages, you can call functions with wrong number of arguments. It will figure out how to put a 0 or again an empty record or whatever to fill the gaps. So that's why OPA features strong static typing, but without hassles. It's very easy to program with OPA. You don't have to care too much about the types. They're just here to help you. So a real program, I don't know how much time is left.
We want to leave a little bit of time for questions, and
okay.
We want to be in the hall talking to you individually at 2:30.
Okay, so
unless you want us to be barging in with questions all the time.
Okay, no, perfect. So I just want, it's 5 minutes still left with this one. So it's a small web chat. So we can do a small web chat in OPA. So you connect and you chat. And this is just this long of code. This is the whole code of a web chat. Nothing missing here. I will zoom into it. This is the first part, is an object which we use for event-based programming in OPA and for what we call real-time web features on networks. So we make a room, a chat room, which is a network of things. As we said, the chat room will contain the messages, and previously we told that exposed is what we have to write if we agree to share those messages with any client. If we don't, there will be many calls between the client and the server to get around it. But here we can say, okay, every client can have the whole access to the messages. So we expose it. And we type it. So we say, okay, we will use type message equals string author, string text. And we can enforce the network to be of that type. So we say, okay, network will be a network of message that we just defined, and we call it room, and that's the room value, variable. Function user updates is what we saw in the beginning. Very easy. We just define a bit of a fragment of HTML. We put it in the line value, and then here we append the line content to the conversation ID, and then we have some standard library calls to scroll to the bottom of the page. The broadcast function is one function where we broadcast X, which is a message, but this is inferred by the compiler. If you don't put a message, if you send a string, the compiler will tell you, not the bad type. We send it to the room, and we clear the entry value. And the function main is the one which is displayed every time a new client connects. For brevity, the author is just a random string. Send is a function here, so it's an anonymous function that we store into the send value. So we broadcast author and the text we get it from the entry value, from the entry ID, sorry. And here we construct our interface, and what we say is on this div conversation, when it's ready, when it's displayed already in the browser, we will call a function which add a callback to the user update function with the room, which means that every time a new client connects, when the browser is ready, what happens is that the client registers himself for the callback to display a new message every time a new message arrives. And basically, the footer is just a way to connect the input and the button to send a new message, and send being the function which is here. And that's it. And we just start a server. We can have some static resources like CSS that we could register, title a chat, and that's a chat. So we can run it if you want to. Anyway, if I'm running out of time, I won't show it, but you can do it without any problem. Okay, so that's the chat, and the same one using Bootstrap, for instance, which is very easy to embed in OPA. Okay, so that's opalang.org. I wish you'll join us in the open source community around OPA, because OPA is open source. I don't remember if I told it. And basically, I can, if we have 2 minutes before questions, and I can find this. If you go to opalang.org/c.xmlt, it's apps. It's the apps tab on opalang.org. You can see there are many big and small applications developed in OPA. A few of them are quite big applications, like you will see, like jetleak.com. It's a trip building Facebook app. We can have some 3D editing with HTML5. This is pure OPA, so this is here we can add cubes in the 3D world, and we can select some cubes and move them and stuff like this. You can play Tetris. So, for instance, this is a pure HTML5 Tetris in OPA. So this is only HTML5. I guess there are no single images in it. And it would be very easy using sessions to do a distributed Tetris. So you could make a multiplayer Tetris like the one on Wii with 4 players. If you want to play with OPA, that's a good exercise. There's not much modification to do to the code to start from this, add a session, the same one as the chat room, and make it a multiplayer game, and sharing as a state the position of the pieces for all players. You see, it's not that hard, and the typing system will help you a lot. If you write something which is bad, the typer will tell you most of the time that, okay, no, this is of value tile, and you're using a value game, etc. So you can't make much mistakes. And those are some small example. So we have an Eclipse plugin, anyway, yeah. And internationalization support. So yeah, many features indeed. Okay, questions?
Thank you. I'm an old Lisp hacker, so this idea of having to fiddle around with types and then the strong typing thing, just drives me crazy. It seems like everybody's so proud of their workarounds for it, and I'd like you to speak to that for a moment. I have a second question, which is there have been these web creation tools forever, and I'm thinking about my friends that made this one called Water. I don't know if you ever run into this company, Water, with the tool called Steam, and they basically, what they say is it's Lisp with angled brackets, so lets a person that is used to dynamic storage allocation and flexible typing and all of those other things make their way. Hasn't taken over the world. Anyway, comments on those two things would be interesting.
Okay, so first, dynamic typing à la Lisp versus strong static typing. It's true that many developers are used to dynamic programming and find it cool. Especially in Lisp, many developers like the reflexivity of the program and to evaluate expression that they are building on the fly, etc., etc. This does not produce readable code at all, and this is, there are many talented and bright developers who use this, but building a very complex system with such dynamically typed language is much more work than building it with strongly statically typed languages. For many years, people opposed strongly statically typed programming because of the burden it puts on the developer. When designing OPA, we really tried to make it simple. I take an example. I've been developing for 15 years in OCaml, and OPA is mostly implemented in OCaml. One thing that, and I taught OCaml for several years, one thing that most people don't get about OCaml and get pissed off by it is the way the records work. Basically, you can't use a record before creating a type. And then you can't have a field name which is shared by several types in the same namespace, which usually happen to be quite big because you have a main namespace where you have many things in it. And this is something that is very tedious and one of the hurdles when doing quantitative typing. We remove this with OPA. With OPA, the polymorphic extensible records allow you to deal with complex data structure much more easily and at the expense of us having a lot of work in writing the typer itself. So we hope we, as we say in Silicon Valley, cracked it with the typing system of OPA. And second question, yeah, we're not the first to design a programming language for web apps. We try to be clean, single, etc. My guess is there is now a generational change happening because of HTML5 specifically, and because of event-based programming. The web apps now tend to be more and more reactive, and they tend to use the HTML5 features a lot. And I hope that with this new technology shift, we'll be the one to win with OPA.
I'm hoping that some other people can ask some questions, so I'm going to just encourage that.
Martin had a question.
Yeah, I had my question about the debugging. So
Yeah, that's all right.
people compile execute language. You seem to debug something that compile, but the rest
In JavaScript.
in JavaScript.
It's true. So currently, we don't have enough good debugging tools, and there are several I could think of. And currently, debugging is pretty hard. But hopefully, in really developing with OPA, the typing system catches enough bugs to have few things to debug. So it's true that there are still some things to debug. I can think, for instance, of events who are not caught by the browsers for several different reasons. And this is to debug manually, so with the printf old method.
All of the preprocessor-based languages have this problem of either you've got to have some environment that supports you more, or you need maybe an interpreter version of OPA that you can interact with.
Yeah. But there are still things we do. So we have, if you compile with OPA -- debug.js, basically we have, OPA is made with a lot of passes in the compiler. So the OPA compiler is about 100 passes. And so small step passes. And we use unique IDs to track back parts of the AST to all these 100 passes. So if it goes up to the generated JavaScript if you put -- debug.js, so you can have those unique identifiers and trace it back to the original code. So we do have this. What we don't have is like a GUI to make it point and click.
We had another question in the back.
Yeah.
Just a curiosity, is the choice of license on the open source related to your business model?
That's another very good question. Yes, it is. And the other thing is that we've got a lot of feedback about the community, especially people in big name companies here in the Silicon Valley who tell us that the current licensing model is really a barrier for them. And we are strongly thinking about changing it to, and we're doing BSD or Apache license for the standard library. So we will probably don't change the license of the compiler itself, because if you're just developing application in OPA and want to run them freely, whatever, when you want, under the license you want, you don't need the compiler in it. But we'll probably change and loosen the restrictions and release the standard library under an Apache license or the like, so that you can effectively use OPA to more freely for your own application. But we will not change it for the compiler.
Question from the outside world: Do participating developers code in Alchemy or
In OCaml?
Yeah.
No, I guess that many developers we have now in the OPA community come from web development and didn't have prior experience with functional programming languages. So even OCaml.
And the follow-up was, is there a plan to oppize OPA.
Is there a plan, sorry, too?
To oppize OPA.
Oh, yeah, of course, to bootstrap. Yes, indeed there is, but there are a few problems that we need to solve, and currently we are focused on more features. So as a research perspective, it would be very interesting to bootstrap OPA, but we have to add some features regarding the 100 passes in the compiler, because what's painful is to do term rewriting on the compiler. So if we had some term rewriting support in OPA, it will be much easier to bootstrap OPA. But yeah, that's one thing that would be very interesting from a research point of view. But right now we are focused on features and web features mostly.
Right, and then how big is the community? That's one question. Another question. There's a lot of questions. So
yeah, of course. So the community, currently we have about 30,000 visitors per month on opalang.org. So this is pretty big jump since we just released in June. We were the front page of InfoWorld.com last week, indeed, and that, for instance, also draws a lot of traffic. I would say that maybe 10,000 people have toyed with it, playing with Hello World. Let's say 10,000 Hello World, and several hundred, maybe about 500 people who actually developed new and real programs with it. So yeah.
We're running low on time. I'm just wondering, is there one more question here? Maybe.
There is SQL binding, and also if you want to call some Java libraries or something like that.
Yeah, so SQL binding currently no. So we have bindings for MongoDB and CouchDB. So two NoSQL databases currently. Support for SQL database is feasible. It just wasn't too much a request, and but it's feasible. Could be a community contribution, for instance. And the other part of your question, how to sync with other programming languages, including Java. The best way is to do it through RESTful services. So OPA supports both RESTful clients, RESTful servers, and makes it very easy to interact with other web code, whatever the language.
So I think at this point we're going to take the rest of the questions out in the hallway. Please join us for soda and some cookies, and thank you for coming.
Thank you for attending.